This video is going to consist of some quick examples of using the shortcut for derivatives with the power rule. And so we're covering section 2.2 out of our book. This is the original function here, f of x equals 3x to the fourth, 2x cubed minus 5x squared minus 2x plus 3. And by the power rule, we know that we can take the exponent, which was the 4, multiply it by the coefficient. So we'll get 12x, and then we can subtract power by 1 and give us 3. And we can do that same thing for all parts of the polynomial. So we'll wind up with the 3 times the 2, which give us 6. Subtract power by 1, 6x squared there. Then we're going to wind up with negative 10x to the first minus 2, and then the derivative of any constant is 0. So there's our derivative of 12x cubed plus 6x squared minus 10x minus 2, just simply using the power rule for that one. Looking at a different one, we have to rewrite this one because we can't use the power rule right away. So we're going to use our rules of exponents that we learned in Algebra 1, and we know that we can write it by bringing the x cubed up top and making it negative. So now we can apply the power rule. So f prime, or our derivative, negative 3 times the 5 is negative 15. Subtract power by 1 gives us negative 4. And we'll clean this up with no negative exponents. So our derivative is negative 15 over x to the positive 4. And then looking at a couple more examples, we've got h of x is equal to the cube root of 8x squared. Again, the first thing we need to do is rewrite this as 8x squared to the 1/3 power, because the cube root and 1/3 power are the same. Then we have to distribute the 1/3 power. So the 1/3 goes to the 8 and to the x squared. 8 to the 1/3, x to the 2/3, because power to a power, we multiply. 8 to the 1/3, or the cube root of 8, is 2. And then we have x to the 2/3. So this is our new h of x. Now the derivative, by power rule, we bring the 2/3 times the 2, so that gives us 4/3 x, and then we need to subtract 1, so that's like subtracting 3/3, gives us a negative 1/3 for that. And again, no negative exponents, so our final derivative here is going to be 4 over 3x to the positive 1/3, or if you had to write it with the radical notation here, we got 4 over 3, and then we have the cube root of x. You could write it that way as well. So now combining this, what we learned with last section, with the equation of the tangent line, let's say we have the following here, where we have the function x cubed minus x plus 1, which is this graph right here, and then at the point 1, 1, which is right here on the graph, we want to know the equation of the tangent line that goes with it. So it starts off, find the derivative, and we'll have 3x squared minus 1, power rule here, power rule there. And so the derivative, which is the equation that represents the slope of the tangent line, now we have to plug in 1. And we'll wind up with 3, 1 squared minus 1, so that's going to be 3 minus 1, and we'll get 2. Now 2 represents our slope. So we can use point slope form now, y minus y1, so there's your x and your y for your point, equals 2x minus 1. So now if we're using this, and if actually it's easier if to graph it in slope-intercept form, we know that y minus 1 equals 2x minus 2, and therefore we know that y equals 2x, and then that's going to be minus 1. So if I graph this in slope-intercept form like I learned in Algebra 1, I start at negative 1, and I have a rise of 2 over 1, and then this way I'll actually wind up with a nice straight line that's tangent going through the point right here that was 1, 1. So there's some 4 quick examples of reviewing the derivative from section 2.2.